Hey guys, it's Miss Gill here. We are moving on to lesson 1.3, modeling with linear functions. So with this lesson, by the end of the lesson, you should be able to write equations of linear functions, compare linear equations to solve real life problems. Now, in the past, the biggest issue that I've had with students is them interpreting the slope, putting it into words. What does the slope mean? So that's something that we're going to focus on in this lesson. Also, want you to notice right here the key idea. These are all review. So if you have an equation in the form of y equals mx plus b, that's slope-intercept form. We sometimes may need to use point-slope form, so maybe we know the slope and we know a point, we would use this one. Typically you would use this one when you know the slope and the y-intercept. And then if we need to find the slope, remember this is our points. We subtract the y values over the x values. So maybe we need to add that because they don't really have that here. So I'm going to add that real quick under here. All right, so you subtract your y values over your x values, just as a refresher. Again, this is all review. So let's just dive in and get started. So we're writing a linear equation and interpreting slope. The graph above, so talking about this graph right here, shows the distance your friend hikes in x hours. Write an equation of the line and interpret the slope. So we're looking for what information is given to us. So I can see right here that this is my y-intercept. So I'm given the y-intercept. And I'm given a point. So I got two options. I could use point-slope form because we're given a point, we can find the slope, or we can use slope-intercept form. I think most of you are familiar with this, and this is the easiest one. So this is the one we're going to go with. But in order to do that, we need to find our slope. So what is our rise over run? So that's one way you can look at it. Or if you were to substitute these values then. So if we took our y2 value and subtracted our y1, well, what is our y-intercept? 0, 0. So since our y-intercept is 0, 0 in this case, we're doing 24.5 minus 0 over 7 minus 0. So we're able to actually just look at this point in reference to our slope since we have that. So let's go with that. So we got 24.5 minus 0, which we know is that. We have 7 minus 0, which we know is that. I don't have the fancy calculator with me at the moment, so I'm going to use the old school calculator, and I'm just going to divide this. And we get 3.5. So our slope is 3.5. We need to write an equation. Well, if I know the slope and I know the y-intercept, I can use slope-intercept form. So let's go ahead and do that. So I got y equals mx plus b, where my b is my y-intercept, which is 0, and my slope is 3.5. Is it necessary to have this plus 0 there? No, we can erase it. Well, I can erase it, or you could rewrite it. It's up to you. All right, so we have y equals 3.5x. That is your equation. So we did this part. Now we need to interpret the slope. So what does the slope mean? Well, we know it's increasing. So something is happening per hour. That's what we're looking for. What is happening per hour? So we have distance. So how many miles per hour is our friend hiking? So miles per hour. So if we look, we found our slope is 3.5. That happens to work out nicely for us. So we're able to say that our friend hikes 3.5 miles per hour. All right, so that's our interpret slope. Make sure that you are doing both things. So we wrote our equation, that's right here, and we interpreted our slope, and that is right there. Okay, so we're going to do the same thing again. I picked this one because this one is weird. It's a little different. Usually our miles is on our y-axis, and it's a little different this time. So it makes you really think. So that's why I chose to do this one. So again, we are writing an equation of the line, and we are introduce the slope. Nope, that's not the right word. That should be interpret. All right, hopefully by the time you get this, your copy does not say introduce, because I haven't made copies yet. All right, so we're looking at a gasoline tank. We're looking at fuels per gallon, and we're looking at distance in miles. So I see that this line is decreasing. So that means that I'm losing fuel for every mile. All right, so remember, your slope is like your unit rate per one. So that's why it's a little weird. Normally we talk miles per gallon, but in this case we're doing gallons per mile. So it's a little awkward, but be patient. They even give us the slope, all right? They tell us the rise is 3 down, our run is 90 over, and they give us our y-intercept. So what is our y-intercept? Well, each one of these is counting by 2. So if this is 8, that's 10. That means this one is 12. So our y-intercept is 12. So let's take our slope. We know it's negative because our line is decreasing. We have 3 over 90. And so we just need to simplify. This becomes negative 1 over 30. And we know our y-intercept is 12. So we're going to write y equals negative 1 over 30x plus 12. So this wasn't the too awkward part. The awkward part is the interpreting the slope part. Because, like I said, we're used to saying miles per gallon. Now we have to say gallons per mile. So what is happening? It is losing, and the gas tank is losing 1/30th of a gallon every mile. All right, so we would say that the gasoline tank uses 1/30th of a gallon for every mile. So you may say, well, Miss Gill, isn't that the same as saying 30 gallons or 30 miles per gallon? Yes, but that is not how we're talking. Our Y is our gallons of fuel and our distance is miles. So just important that you're interpreting it in the sense that they are giving it to us. Okay. If you have questions about any of these, again, as I go through these, put a star by it. Make a note. You got room over here. Make a note. Ms. Gill, I'm still confused. Something like that, and we can always talk about it. Okay. So let's go into a word problem, and let's see what they want us to do. So the graph shows the distance asteroid 2019 GC6 travels in X seconds. Write an equation of the line. So we got to do that. Write an equation of the line and interpret the slope. At least I got it right that time. An asteroid came within 136,000 miles of Earth in April of 2019. About how long does it take the asteroid to travel that distance? So we have a third part. All right, we have 3 things we have to answer here. We got to write the equation, we have to interpret the slope, and we have to figure out how long it takes to travel that distance. So let's start with writing an equation. So looking over here, I see my y-intercept is right there. They give me this point. So just like our first example with our friend that was hiking, we could 21 minus 0, 6 minus 0 to get our slope. So we say our slope is 21 minus 0 is 21, 6 minus 0 is 6. So if we divide that into a calculator, again, we get 3.5. That's weird. All right, so 3.5 is our slope. And now we got to write an equation of line. That is so weird that both of the equations are going to be exactly the same, but it just came up with, well, I added the other one, so maybe, whatever. Just ignore me at this moment until now. All right, so we're writing the equation. Back to it. Miss Gill is losing her mind. All right, so our slope we said is 3.5x plus our y-intercept is 0. Is it necessary to write the 0 there? No, we're just going to leave it like that. So we wrote an equation of our line. So this is part 1, right? But they also want us to interpret our slope. So in this situation, what does our slope mean? Well, we're talking about an asteroid. We're dealing with miles per second. So what does that mean? Well, our slope is 3.5, so that means that our asteroid travels 3.5 miles per second. All right, so about how long does the asteroid take to travel the distance? So what distance? This 136,000 miles. So what is our miles? Our miles is our y value, all right? Our time is our second. So they're asking us how long does it take? So that means we're looking for our x. So we don't know the x, we do know the y. So we're going to use this equation to find our x. So instead of y, we know that y we're looking for when y is 136,000 miles. We want to know how many miles did it travel. So we're just going to divide both sides by our coefficient, which is 3.5. And we get x equals, let's see, so 136 divided by 3.5, and we have a long number. Well, kind of long. So we have 3,888,57, and then we got a decimal. So let's go whole numbers because there's no sense in having a decimal second, if that makes sense, because we're talking about time, right? How much time? We don't usually say, oh, it took her 0.2 seconds to come up with that. No, we don't talk like that. So we're going to round to whole numbers. After the decimal is 1, so 1 says let it rest. So we're going to write just that number down. So x is approximately, so wavy equal sign, 38,857. But since we have a word problem, that means our answer has to be in words because it doesn't say what is x, and that's all I have is x, right? We have to answer a question in words. About how long does it take the asteroid to travel that distance? So you have to put that part into words. So I was writing this and then I was like, we don't talk in seconds either. Like you don't say, hey, so-and-so was gone from the classroom for 352 seconds. That was a long time. We don't talk like that either. So let's determine a new measurement that we could turn seconds into. So we know this is a lot of seconds. So if I take this and I know that there's 60 seconds in every minute, right? So let's say if we want to find out in minutes. All right, so we want to find out minutes. We take the number and we divide it by 60. This will tell us how many minutes that is. So we got 38857 divided by 60. So that's still a lot of minutes, right? Let's go approximately 6. All right, we're gonna just go whole number. Let's go 648 minutes. All right, but that's still a lot. We still wouldn't be like, hey, I went home and worked on my project for 210 minutes, right? So what's another method? What about instead of minutes, we go to hours? So we know that there are 60 minutes in an hour, right? So if we take 648, we divide it by 60, we get 10.8. So let's round that to whole hours. So take away my straight line. Let's make it an approximate 11 hours. All right. If this part confused you, just let me know. We're just converting from seconds to hours. Could you have said, I know that this number is so big, I want to go straight to hours? Yes, you could have divided by 3,600. How do we know? Because 60 times 60 is 3,600. So you could have done that as well. So it takes the asteroid about 11 hours to travel 136,000 miles. All right, so that sounds a little more like 11 hours. Okay, now we have a little better understanding of what kind of time that is. Okay, we have one question left. This one does take a little bit of time, but these are the type of problems that they love to give you. All right, so we're comparing linear equations. Two prom venues charge a rental fee plus a fee per student. The table shows the total cost in dollars for different number of students at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented by the equation below. Which venue charges a greater rental fee? How many students must attend for the total cost to be the same? So let's talk about this. We first need to be able to compare them, right? Well, we have slope-intercept form here. So in order to compare them, I need to take this information and turn it into an equation in slope-intercept form. All right, so where could we start? We could start by finding the slope. How do we find the slope? We find the change in our y values over the change in our x values. So if I take 1800 and subtract 1500, I get 300. If I take 125 and subtract 100, I get 25. And that's the same regardless of where I go, all right? And 300 again. So how do I find the slope? I take my 300, right, because y over x. So I find my slope by saying, well, 300 over 25, so my change in my y over my change in my x, and that gives me 12, right? 25, 4, and yeah, because there's 4 25s per 100. I'm mathing in my head. All right, so now we have the slope. Do we know the y-intercept? No. Could we sit here and manually be like, okay, minus 25, minus 300? Some of y'all may do that. But if you recall from the beginning, we were given some different formulas. So let's use point slope form. So we're given the slope, or we found the slope, and we're given a point. We're going to do point slope form. All right, so let's go. I'm going to give us some room to answer those questions. So I'm going to kind of come down a little bit before I start working. So our formula is y minus y1 equals m times x minus x1. All right, where y1 and x1 is a point. So let's just go with the smallest points, right? Let's make this x1. Let's make this one y1. All right, so I'm going to plug that in. So my y is 1500, my x is 100, and my slope is 12. Oh, I put that in the wrong spot. My apologies. We got x minus 100. And just bring the rest down. We should end with a y and an x in our equation because remember, we're trying to make it match up to this. All right, so now let's solve. How do we solve? We need to distribute that 12. All right, so we're going to do that. So we got y minus 1500 equals 12 times x, which is 12x, minus 12 times 100, which would just be 1200. All right, need to solve for y, so we need to get rid of that 1500. So let's move the 1500 to the other side. And we can bring down our y on this side. We have 12x, negative 1200 plus 500 gives me 300. So this is the equation for Lakeside Inn. So I'm going to move my paper back down. I'm going to write this equation up here. All right, so now we know Lakeside Inn, Lakeside, equation is y equals 12x plus 300. So now I can compare these, right? I can compare this with comparing that. So now let's answer some questions. Which venue charges a greater rental fee? All right, so what part of the equation represents our rental fee? So let's think, all right, what will change the number of students, right? The rental fee wouldn't change. The rental fee would be like a standard fee. So we don't want our slope because that is the number we're going to multiply to our students, right? So that means that this is our initial value. So that would be our rental fee. So what does that mean about the slope? Because I need you guys to know the difference. Like, what does the slope mean in this situation? The slope is like what the cost per students would be. So you would multiply, where is it? The table shows the total cost. So we would multiply the cost per student. So we would say that the 12 our slope because X is our number of students. So we would say this is the cost per student. So if you're asked who has the lower cost per student, we would go with this one because this one's 10. So we would say Sunview has the lower cost per student. However, we're looking at answering which venue charges a greater rental fee. So who costs more? Well, Sunview is 600, Lakeside is 300. So Sunview is our winner. Sunview charges more. All right, so how many? So we had to do all of that just to answer that question. So how many students must attend for the total cost to be the same? Well, what's another math word for same? Equal. So what does that mean? We're going to set them equal to each other. All right, so we're going to take 10x plus 600, 12x plus 300, and set them equal to each other. I'm going to do that right here. So we're going to basically say Sunview and equal Lakeside. All right, so we're going to set Sunview equal to Lakeside. So Sunview, our equation was 10x plus 600. We're dropping the y. All right, and then because if you remember from systems of equations, if they both have y, you can use substitution. Same kind of idea. And so then this was our equation for Lakeside. So now we need to know how many students. Well, what represents our students? X. So we're looking for how many students would make Sunview's price equal to Lakeside's price. So we're just going to solve for X. All right, we're just solving a multi-equation. So I'm looking at my X's. I got 10x over here, 12x over here. I don't want to deal with negative X's, so I'm going to get rid of the smaller one. All right, so now I have 600 equals, well, what's 12x minus 10x? 2x plus 300. So now I just have a two-step equation. We should all be professionals at this point on solving two-step equations, but I will show my work. So we subtracted 300 both sides. We got 300 equals 2x. I don't want two x's, I just want one. And we have x is equal to 150. So what does that mean? That means that if there are 150 students, it doesn't matter which venue they use because it would cost the same. Now, if you have less than 150, one of them would be the better deal. If you had more than 150 students, then another one would be a better deal. But if we had 150 students, the cost would be the same. All right, so right here, remember, you got a word problem. Your answers should be in words. The total costs are the same when 150 students attend prom. So that is it for lesson 3. Your big takeaway should be how to interpret the slope because we should know how to find the slope. Again, if any of this you have questions, make a note of it. Ask me when we come into class. If a lot of people have the same kind of question, I can go over it as a whole class. If not that many people, then we can work and we can talk in a small group. All right, so I will see you guys in class.